4.5. A quantitative research process allows a researcher to pick a specific topic of interest, to then conduct an experiment, only collecting numerical data. Once the data is collected, there are a variety of ways to organise it. When presenting and collecting data, a researcher needs to organise it, as then it makes it more manageable and easier for the researcher to interpret. The first method of organising the data could be through using the range. The range is the calculated difference between the highest value and the lowest value of a dataset. The method of calculation consists of subtracting the lowest value from the highest value. This can be conveyed in Figure 1, as the highest sit and reach score is 56 and the lowest is 25, so 56 take away 25 equals 31. Therefore, the sit and reach range is 31. The purpose of the range is for the researcher to establish how much of a difference there is between the data collected. It is useful to see how closely related the values are to determine if the data can be trusted. The data might become less important if there is an anomaly, a number that is not close to the other values, so it stands out on its own, and that is known as the anomaly. This value causes an effect on the data as it disturbs the researcher from seeing the difference between numbers that are close together, therefore hinders how much of a difference there is between the values. An example of this could be if the researcher had the values of 1, 2, 2, 3, 4 and 11 centimetres for the sit and reach scores. The anomaly would be 11 as it is not in close proximity to the other values, so the range of this data would be 10, as 11 take away 1 is 10, showing the difference of the highest value to the lowest value. But the data doesn't represent the majority of the scores collected, as most of the scores are under 5. So this range does not truly convey people's scores and their ability. A researcher can organise their data through rank order. The data can be presented from the lowest to the highest, or highest to the lowest value. The data is in a single column so that it is easy to analyse which is the best or worst score. Dependent on what data you are analysing depends on which way round your data is presented. For instance, Figure 2 shows the raw data and how I have transferred it to rank order. The peak flow scores are ordered from highest to lowest. This is because the highest peak flow score represents the best. The higher the score is, the better they have done, as a larger exhalation is better. Whereas the sprint scores are ordered from lowest to highest. This is because the lower your time, the faster you are. So the lowest score is the best score. Usually, rank order consists of 20 or less values. This is so there is not too much data, otherwise there will be too much data to handle. The purpose of organising the data this way is to recognise the best score from the worst, so that the researcher can gauge an idea of the participant's ability in certain aspects of fitness testing. A researcher can use simple frequency distribution to organise their data. It consists of having all of the scores in a table, but if there is a recurring score, you just represent it once in the score column, and then the many times it occurs in the frequency column. The purpose of organising the data in this way is to see how many times a score or piece of data appears. It is used when the range is less than or equal to 20. This is because the data is more manageable and easier to analyse. However, you can use more than 2 columns to represent the data. With Figure 4, I have used 4 columns. This is to represent the scores, tally, frequency, and cumulative frequency. Cumulative frequency is when you add the previous frequencies to the next. So looking at Figure 3, you can see I have the bicep skinfold caliper raw scores to the left, and then in Figure 4 I have the scores within the table that show the tally of how many times the scores appear, the numerical value for the frequency, and then the scores collected together. showing the cumulative frequency. Next, the researcher could use group frequency distribution to organise their data. It is used when there is more than 20 values and the range is greater than 21. Grouped frequency distribution is when the researcher groups the values, for example, from 0 to 5 or 6 to 10. The data is still presented into columns to find the frequency of the different values, but with this method you can insert a larger volume of data as the values are grouped. The aim of this method is still to see how many times a value appears. It's just now it will be grouped instead of a singular number. Ideally you have 15 groups, but you can have up to 20. More than 20 groups will make it confusing for the researcher, as there will be too much of a large volume of data to handle. To find the interval size of each group, you calculate the range and then divide it by 15. Shown in figure 6, I have calculated the intervals by dividing 41 by 15, as 41 is the range of the vertical jump scores, consequently getting the intervals of 2.7. That I have rounded up to 3. Shown in figure 6 is my grouped frequency distribution of the vertical jump scores of the gymnast. The reason there is 14 rows is because the intervals were just under 3. Therefore, 14 rows fits perfectly with the number of scores I had. Figure 5 just indicates the raw data that I have converted into the table.